So I am the mistaked professor, and I'm going to make a lot of mistakes. And today we're going to fix this mistake, hopefully. The problem with this particular thing is that I didn't want to use that one formula that I had put on here. I said, no, we'll never use that formula. Nope, this time we are. Because we have two different G's. That's what's going on here. What I was trying to do was an algebraic method. I was trying to solve for, both and plug them back in, make it easier. Before class, we even did it algebraically, and still I got the same answer I did last time. So I'm missing something. It's that I need to have each of these G's independent in a way. That's all. So that's my goal here. Now notice there's one thing. This is a lambda, right? That's the lambda. But then this is a mu. And so we have another variable included in here. Not just 3, not just 4, but 5 variables now. And that's okay. We're going to try it. It's as soon as I saw this problem though, this formula, I'm like, "Oh yeah. There it is." I know y'all are going to like copy it down or something cuz I also couldn't copy it down. I'm going to copy it down too. Good. Good. I'm going to scroll and copy it. Here we go. Yes. Yes, indeed. So we got grad f is equal to lambda grad g1 plus mu grad g2. All right. Oh, yeah. And yes, you said g1 is equal to 0, g2 is equal to 0. All right. So if I move my constants over, you can see that I got my two different g's, and that's happy zone, I guess. So let's go back and keep doing what we do. My f is supposed to be that distance formula still, right? So in a way, it's kind of like I'm still like lost here. I can't do it yet. Just that distance squared formula. We'll get back to that in just a minute, okay? Let's start with the things that I can do. Can I do a grad g1? What's my grad g1? Okay, awesome. Grad G2. Sweet, sweet. Okay, so we got those guys. You can see that those are going to be pretty easy. We have these stuff here. So what would be that grad F business? So going back to that formula, distance squared was some p vector, which we're going to use here in just a second. I still think XYZ might be a good answer there. And so then we also have here our other vector, which was the normal vector. I had gotten it from the intersection between these two guys. I might still do that. And then we're going to have that same vector in the bottom. And then I'm going to square it. Like I'm going to square the whole thing. Yes, and it's cross in the middle between these guys, right? So I'm thinking that it's still going to be XYZ, I think. And I really should go check my math live here in a second. And then here, again, it was the slopes of the intersection. And again, we had done this, and I'm just going to redo it just in case. I think that we are going down the right road, but now that we have these two G's, we might be able to get it. But let's just triple check here. So I move this over. No. I move this over and get y is equal to 6 minus x, and then I plug that in. And so then I got 6 minus x plus 2z is equal to 12. Move this guy over. So negative x plus 2z is equal to 6. And that's how I had my slopes of negative 1, 0, and 2. Negative 1, 0, and 2. Negative 1, 0, and 2. This is still my assumption for my f. What I want to do before I go forward is I want to go to the homework. We have it up. I'm just going to pull it up and I'm going to flash it and see, are we on the right zone? Are we in the right direction here? You still don't like that, James, I know. Right. The only difference is now that we have other G's, I think. I hope. This is my assumption. I know it should be We were pretty close. I feel we're close down our zone. See, again, I did the same style both algebraically before class here and with the calculus 3 stuff. We got the same answers. So there's something right, but there's something also wrong. And so let's go to the homework. I want to look. And so this was the homework problem, and we did the view example. And so what I did is I looked here and I was like, oh, there's the formula. So, okay, what do they have here? They have f is equal to, oh, look. As I said, right? Didn't I say the distance squared to make it easier, right? But look how they've done it. They didn't go crazy formula. They just said, what's the distance formula? And you're like, Pythagorean theorem, duh. I see now. And so this is why we have view an example for times for like me. So I was right in the concept. I was wrong in the formula. And man, doesn't that make it so much easier? And so then x squared, y squared, z squared. So much better. So I'm just going to verify, are y'all okay with the concept there? Still giving me that dirty look?
Oh, no, I was trying to think.
Okay.
Ignore me.
Are you okay with the fact that this is a distance formula?
I mean, it makes sense here. Just since the distance is squared and you're squaring your x, y, and z, which tells you your positions, that should be fine.
Like the original is obviously this guy, but nobody wants a derivative of that thing. It's just dirty. So then what we all do is we square it like they were showing, and then it's so much easier to do. So then I can say grad f, and we get that 2x, the 2y, the 2z that they had. So again, I feel like I was so close. Would you give me points back on a test? I had the right concept, okay? It's just funny that way. Well, here we go then. So I have this thing. We're going to go toss them all together, and here we go. So for my x's, I'm looking at here, here, and here. So I got 2x is equal to lambda times 0 plus mu times 1. Repeat for the y's. Lambda times 1, mu times 1, lambda times 2, and mu times 0. They really did help us a lot here because the zeros make things so much nicer. Like basically you just found that mu is equal to 2x. You found that lambda is equal to z. And therefore 2y plus z, or I'm sorry, equals, my bad, equals. I'm just going to plug them in now. Equals z plus 2x. Like basically I'm just like tossing these both in here and here to be able to get the right answer. Yeah. You have the studied look on you.
Well, I was trying to align boxes in my head, if that makes sense.
Me too. So what we have right now is this happy little thing, okay? We also have these happy little things right here. How many happy little things do we have? 3. How many variables do we need? 3. See how that matches up? So everything's happy at this point. Let me rewrite them all so that I'm just going to start. No, we don't need that now. No, let's do this. It is kind of like a system of equations at this point. Let me just recopy what we got. I got a y plus 2z is equal to 12. I have an x plus a y is equal to 6. And then I got this new thing, 2y is equal to z plus 2x. Like this is everything I need. I'm going to zoom in, and we're going to start doing math down here now. So this was the top two from the top, and then this is my new one over there, and we just start solving. I think I'm going to solve for z down here. So like if I move this over, so then I got z is equal to 2. No, it is not that. It's negative 2x plus 2y. Do you agree with me? And then I take that and I can plug it in here. So then y plus 2 times all this stuff is equal to 12. Combining like terms, I would have 5y, a negative 4x. Ew. Guess I'm going to move it over and divide. So then now I got x is equal to 12 minus 5y all over a negative 4. If I want to clean it up, it's a little bit better, right? Plug that in over here. I was doing so good. Thank you. Thank you. And this is why I look at your scrap paper stuff because even I make mistakes. I'm going to the middle term, by the way, here. This middle one equals 6. No. It is plus y equals 6. Okay. So this is 4 over 4, 5 over 4. That's 9 over 4. Move this guy over to get a 9. So 9 over 4 y is equal to 9. Multiply by 4, divide by the 9. Y equals 4. Woo! We're getting somewhere. Finally. And now I can plug it back in. So x is equal to negative 12 times 5, or minus 4 times 5, 5 times 4, divided by 4. So that's a 10. So we got a 2. Am I supposed to get a half? No, that's 20. Yeah, that'd probably be easier. But you know I'm going to take the most challenging road every time. And then my z way over here. So negative 2 times 2 plus 2 times the 4. Negative 4 plus 8 is 4. There it is. We got them all. Man. Okay. I learned a lesson today. View an example. And I didn't even finish looking at the whole thing, but it did guide me on how do I get started, right? And when we're just all learning this for the first time, yes, I don't want that one on an exam.
I was gonna make that joke. Like, so, Jen, will we see this on the exam?
I don't want that one on exam. I don't want the 2Gs because it's too much time. We don't got that much time on exams, so I don't want that. The 1G would be fine enough. So here's my my promise. Though I haven't done it, so I feel like I feel bad whenever I do this, and I don't even know if I'm going to do it. But I'm going to do it. Y'all are going to remind me. I'm going to go through every one of these Lagrange problems myself on the exam, and if I'm having a stumble on it, then I would take it off. It has to be something that's reasonable and feasible, time-wise, and for concepts. Like I thought this was a cool problem, like because I tossed all these on here, and I haven't done them in forever. But I was like, oh yeah, the distance. This will be a perfect time to talk about the distance squared, right? Because that's what the point was this. I wanted to say, look, the square of the distance. But then we went down the whole tangent road of like, oh, there's a formula for that. And no. So is that okay though?
I was trying to pay attention because I was getting confused. Can we go back down just to the last step of where we
Yes. Yes. You mean like all this stuff?
Yes, sir. On the left side.
This thing.
Yeah.
Okay, cool. How about I do that? That way you get all of it. Blah blah blah. Answer.
It's gonna take me too long to write down
Right. Exactly. Matrix. Yep. Correct. Correct. Yes. You can use anything. Yep. So that's good. That kind of scares me about the 3D graphs. Since just graph it, just graph it, just graph it. But one. Yeah. I gotta have one of them on there. Good.
Yes, sir.
All right. Cool. I want to do the lab, but because we have two people out today, I'm gonna maybe Mason might come back tomorrow, maybe not, but we'll just maybe do it when everyone's here. Okay. So I can't do that, but we now have the ability to do the lab. That was the point. Was that we had to do this to do the lab. So I'm gonna get started on integrals because this is super easy stuff. Ignore that thing. Um, really what we're doing is just integrating twice. So this is a cool concept. We're going to do a couple and then we'll be gone here in 30 minutes. So is that okay? It's easy stuff. It truly is. Especially right here. This helps a lot, okay? Because what that means is that it's definite integrals with numbers. And numbers in math class also technically means integers. So we're going to do integrals with integers and everything's happy. Okay, so that's the long road short there, I suppose. I'm going to give you one. I know this is really cool and a cool concept, but I want to do one just as an example up here since we've got some nice blank space. Let's do a double integral. And I'm going to go 0 to 1 and then 2 to 3 because I'm super creative like that. And let's just do let's do 2x plus y squared dy dx. Okay, so this is just an example, and it's very simple, and it's fun. It's a fun thing. We're doing concept fun stuff. If there's a hard one, I'm sad because I didn't expect it. There's a set of parentheses, like a grouping that is implied. Okay, this is how that always looks. But what they're trying to say is that there are two separate integrals. We're going to do the first one on the inside, and then we branch out to the next one. So that's kind of like its concept. I want to do this inside one first, which is easy. Both of them are easy. And so when we do double integrals, all I'm going to do is say, okay, we'll leave the outside alone, and heck, just go ahead and put a dx there because we're not doing that yet either. But I do want to do this part. And so if I'm integrating, again, this is like, reverse derivative stuff, right? I'm integrating this little guy in terms of y. I know there's not a y. Therefore, we practically, you leave that number alone and you add a y to it. Very good. It's kind of like a number, right? What's the integral of 2? It's 2x, right? So that's like a really straightforward one. And then I have to do it in terms of y. What do I do there? Mm-hmm. Yep, exactly. Very good, both of y'all got this. Well, there's your answer, and we're going to go from 0 to 1, right? Of course, that's y values. So I'm going to take those and plug them into the y's, right? And let's do that. So I just leave the outside alone. We're still not done with it. Perfect. So 2x times 1 plus basically 1 cubed over 3 is 1/3. And then, like you said, minus 0, essentially, right? Both of them are going to end up being a 0. And there you go. Basically, we just made it all pretty now. Super pretty. Let's do it again. So what's the integral of 2x in terms of x? X squared, very good. you take the x, it goes to x squared divided by 2, but then the 2's cancel. Very good. 1/3. Perfect, perfect. We're going to go 2 to 3 because I'm super imaginative today. Every day. So we're just plugging it in. Of course, the 2's are meaningful this time. So I got 9 plus, well, 3 and 3 cancel, make a 1. So there's that. And then minus, whenever I plug in a 2, I got a 4 plus 2/3. Man, I have a fraction answer? Dang. Calculator, actually. I don't really care anymore.
That's my answer.
Good. At least one of us has good answers. Is it? Hold on. Where'd my little thing go? Right here, we would have a minus for both of these guys. You're right. No, that was good. That was good. Yeah. Probably. I'm just math deficient today. 16/3. Sweet. So in the end, though, the idea is, we're doing concepts here. We do the inside, right? And then we do the one outside of that, and then we keep going. And I like how I did this. This is a really cool way of doing it. They won't ever do it like this because they're all picky about it. They don't like this line here in the middle there. They don't like that, but I do that, so whatever. Normally, what I might do is I might put that line on the outside of it. It just depends. However I feel. Go ahead. Yes, yes. That super picky. You should do y equals, and it probably should go on the outside. Yes, yep, you got it. Yeah, no, yeah, it would be 2xy plus y cubed over 3 dx and 0 to 1 y values. I guess I don't know. Normally, it just kind of like it just happens. I'm just no. It happens, at this point. So, anyways, cool though. It is easy concepts, and that's what we should be focusing on is easy stuff today because that's what we're doing. So let's do it again. Let's do it for this guy. In fact, you know what? I want this is a you do. It's easier than the last one. Y'all do that one for a minute. I'll hang out. And I'm gonna add the big parentheses just as a chat thing. Very good. Yeah. Uh-huh. It won't be as serious going forward because right now it's all numbers. Right now, if you mix them up, you're totally wrong. But eventually they'll have letters to kind of assist. You're going to say, "Oh, I'm going to take a derivative of this, but or an integral of this, but wait, plug that back in." It'll be something like that. As we go forward, it won't be as much of a concern. What I have found though by creating all the quizzes and stuff that MyMathLab focuses on the switching a lot more, and I think they had a whole section just on how to switch dx and dy around, which is a good skill, but they overemphasized it way too much. I think it's easier just to not do that sometimes. So we'll see as we go forward. One of the small things from WebAssign that I do not like is when they do the switching of the dx dy and you have to find all the variations. Those problems in WebAssign are like 20 parts for one question. And at some point it was on an exam. So I removed it because that was dumb. Not good exam material. That was a long time ago, but it's just, yeah. You said something. Now I went blah blah for 5 minutes. So. Are you already done?
Oh yeah,
Oh,
I got really fast with integrals,
good.
and I've already looked into not double integrals, but I looked into triple integrals while waiting for a haircut, so I kind of already get a little.
It's just what you do. Okay.
I don't know. We kept joking around about it. Like I should probably actually look this up.
Cool.
Yes, sir.
That's good. Did you go to Wikipedia?
I watched a YouTube video actually.
Good. Yeah, Wikipedia. I like Wikipedia a lot, but I don't like it for math.
I've tried looking at Wikipedia before for math. That is just
It's insane.
yeah.
Like, I'm so happy all the mathematicians in the world got together, made it the hardest possible way to explain it.
They need like a for dummies kind of it's like triple integrals for dummies that have just triple integrals and just complex stuff.
They have the simplified English version, you know. You're good. You're good. All right. Am I waiting? I'll wait. I don't mind waiting. Finishing it up.
It's the insight math that
That's how I feel. So I'm going to take the integral of this one first, of course. And you're going to help me. So my integral in terms of x, excellent, and very, very good, very good. Sure. I'm going to not be as proper right now. We'll get like a flow going eventually. Yeah, this part is the most annoying because it's like, oh, I have to use a calculator, slowing me down. Yeah. So here's a technique or two. Since we got a cool scientific calculator, you can type in this kind of thing. No, you can't because it has the y's there still, and we need an equation. I was so happy for a minute. Sure. And then so we got 16, and then I'm gonna do a minus, and I'm gonna do this thing 100, right? And then, oh, that one's just the number itself, so that's nice. So then negative 2y, negative 5y. Okay. So then this minus that is 84. Correct, correct. So my integral here would then be, oh, hi Henry. I did, because that's what they gave us. Don't take it down. Make your own first. Pause for a second. Pause. Where's the pause button? So yeah, back to math. So yeah, there's a y here, and then and then 3y squared all over 2, 0 to 1. Thankfully, the 0 makes things easy, right? So negative 84 plus 3 halves times 1, and then the 0 cancels everything out. Calculator time. And then we should be done. We're going to go flash the answers here in a second. Yeah. Yeah, they had, like, I'm just going to be generalized on the recording. So they made the math day poster for us, the flyer, with your brother's face all over it, which was nice. But I had to fix it because like they didn't have the right time thing, and I was just like, "Ugh, I don't even want to bother them. I just do it myself. So I fixed it and then I sent it off, and yep, has official CTC branding. And there we go. We got it. Cool. So I love how they introduce double integrals because it's easy. It really is. And they get a little bit more difficult as we go, but the concept is the same. And really, if you're saying it's difficult because I have to integrate, which you can't always integrate. You can always take a derivative. You can't always integrate. So um, go ahead. I'm saying like this is easy stuff, right? Because we're using numbers. But if I start using letters, then it's a little bit more. If I start saying, oh, well, now I don't know what goes up there, then it gets a little bit more intense. And then sometimes just the integral is something I can't really integrate very well. Like I think we can do that one, but like sometimes they'll do like arctangent squared, and you're like, what? Like I don't know what to do there. Hope for the best. Yeah, so you can't always take an integral, and that's what scares me. But it should be fine. I mean, again, so far it's not been that bad. So notice this little R thingy down here. R stands for region. It's a region. And then eventually they'll use V for volume, meaning 3D. So the region is basically a 2D zone of some kind. On like the 3D graph, we're like saying, hey, it's the shadow of where we're looking. And then everything above it is what we're actually finding. So as an example, when we're integrating like just normally, I'm saying find the area underneath the curve, right? So we're just looking for that. Well, that bottom part, this right here, that would be your region in a way. Is that zone that you're saying, hey, where am I looking? You know, it will not always be a rectangle. That's a rectangle again because we're in the section about rectangles. Sometimes it'll be triangles, sometimes it'll be circles. That's fine. That's not hard. It's just we have to translate this over here, and sometimes. But in this case, super easy. And dA. I'm sorry, one more thing. dA stands for area. So derivative in terms of your area. So region, area, volume, that kind of thing. We'll see all these different words that they just happen. So dA is whatever you want it to be. Generally, what I do is dy dx, but it could be dx dy. That's your call. But then mine, I normally go dy dx. That's just my go-to. So here we go. X, y squared, x squared plus 1. I'm going to do dy dx. I'm going to pause for a second here. You have to make a call at some point. You have to make a decision, right? dA, you're either going to do dy dx or dx dy, your call. But I'm going to say this one. If I'm making that call, then I have to populate this accordingly. This comes first. That goes second, yeah. I I like you. I would say no. But I mean, I'm happy that they did that out of order to make us think that way. That's not bad. Um, I mean, that's how I would do it. But yeah, so in a way, we have to be very careful at this one moment whenever we're like setting it up. I want to make sure that my y's are with the y's, right? So what would I be putting here? And then my x's would be right. And then once you get that, it's all easy street after that. At least I hope. There you go. You did it. And and that's excellent. Let me just roll with that. Um, exactly. Think of this kind of like y squared times all this junk that we don't really care about, and we'll get back to that later, right? My main focus right now will be integrating this y part. And what happens to the y part? Yeah, cubed over 3. Very good. And again, all this other stuff I don't really care about right now. I'll come back to that later. Oh, look, I messed up. I keep doing that. You have to have only one. Once you take the integral, you need to get rid of one of those integrals. That is a very common thing. It happens all the time. Yeah, yeah, yeah. And again, I need to plug in the 0 and the 6. So 6 cubed. Good thing we got a calculator here. You had some of the digits. I think it could actually be divided by 3 also. Let me try that. Since that would be, oh yeah, way better. Way better. And you know what else is way better? What can I do with that 72 to make it even cleaner? Yeah, you just toss it out here. And now we got something way better. Okay. This is where I don't know. You like U sub?
Yeah, because you could get rid of the x to the numerator while turning the denominator into a u.
So you're saying do this dude here
Yes.
and that guy
Then you would divide by the u, which then would get rid of the x to the numerator.
and that guy right there? Oh, there we go. Right, because I divide it to the other side. Go away. Go away. I don't want to X you. I just want you to go away. Go away. Okay. Yes, I'm questioning you because I thought it was funny, but you're right, of course. So I have an x over u du over 2x. Again, this is, if you haven't had any of my calculus before, I always go that extra step so that it's easier. I'll cancel, and I can take that 2 and move it to the front in like 36. Yeah. And now it's much prettier. I'm running out of room again, though. It's a common theme here. What's the integral of 1 over u? Yeah, yeah, definitely. Just as a verify, and this is how because we get caught up in it sometimes. I want to add 1 to the power, right? So it's this guy right now. I want to add 1 to the power, and I want to divide by that new power. So like, does any of that make sense? No. And so that's why it's like that's wrong. It's got to be something else, right? ln. That's how I remember for me. Now I know that y'all have your super awesome brains, but for me, I need a reminder. Like that doesn't make sense. They ln both sides. Like literally, I could show you, but we're not going to go down that road. Yeah, that's an off-camera discussion. But what we're doing here is x equals 0, x equals 1. So what do I have to do? Mm-hmm. No, no, no. No one heard that. Stop. Whenever oh, you know what? Yeah. This is actually it. I think that's it right there. Whenever I plug in the 0, I get 1, and ln of 1 is 0. So it's kind of like it cancels itself out there. Go ahead.
Is ln2 1 or is it ln3 that's 1?
Neither.
Neither? Okay.
This is just a number. ln2 is just a number.
Okay.
Yeah. ln e would be something, and it's close to that, but it's not quite e. Yeah, exactly. Yeah, ln of e is 1, but then like ln of 3 is not. See how we pass it by? Because again, it's ln of 2.71828 essentially. Yes. 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 Yep. Yep. Hey guys, that's what I was doing in algebra today. Look at that. I know. Way back in the day. I don't show them this stuff. No. So not too bad, right? I mean, I'm wanting this to be a nice, easy introduction. So far, so good, right? We're just integrating. We're just integrating. So some things that you might have picked up, and you probably picked up from me regardless, just because I exist. I don't like to put a lot of definite integral symbols around. I just kind of leave it hanging up until the point where I need it.
I'll be honest, that's exactly what I've been doing. I'm like,
Yeah,
focus on just this integral. Okay,
exactly.
focus on the next integral.
Yep, yep, yeah. Correct. Oh, that is very good. Absolute value here. Now, actually, I was thinking about talking about it, but then I drop them here. Why? Good. It's always positive. Very good. Because we got a square that's always positive plus 1 plus. It's positive. It is safe. Oh, I completely agree with you. Yes, this is equivalent and superior. Yes. And that's why we have to do this. Yes. Great point. Great point. Especially for the folks at home. That's good. Because apparently we have a few missing. They'll have to catch up eventually. Um, cool. All right, good though. Good with all this. Great topics. Great talk. This will definitely be the last one of the day. So why do we integrate? So let's just go back to our two-dimensional integral stuff. I'm going to go integral from something to something else. And if I do it in 2D land here, I'm getting an area, right? But now if I'm going to do 3D, in 3D, we get a volume. Very good. And that's why they say volume here. I mean, I'm just making it funny. The idea, though, is that we're just increasing it by a dimension. We went from area, now we're going volume. Cool. So it's like a real application, I suppose. So find the volume bounded above by this guy. So that's my region. That's my region, I think. We're going to figure that out. Oh, no, 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 no. No, 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 no. This is my region. But notice it says bounded above by this much. What does this really mean? I know it's almost implied. There it is. And they say the square here, well, what's my z? And it's basically 0. They're going from the bottom 0 on up, right? Again, in 2D land, when we're integrating, we're always assuming this bottom right here. Happy for us, but that's the same thing going on here. Very good. Right. Well, not today. Not today. I'm going to keep it easy today. So I need to do my integral. And I'm going to pick dy dx unless otherwise. If that's the case, what would I put here at the bottom of this integral? And then, oh yeah, okay. And then, well, yeah. You're right, look at that, 0 and 1. Yeah, okay. Go ahead. Hmm.
So I know, like, you chose to do dy dx, but would it make a difference if we?
No.
Okay.
Not at all.
So it wouldn't make a difference if we were flipping around or
Nope, no difference. 100% fine either way.
Okay, thank you.
Yep. That's not always the case going forward, but here, yes, it's great. Of course, I'm just going to put this guy in, and we're done. Like, well, we got to do the math, but like the setup part sometimes is the hardest part. Once we have it set up, it's just repeated stuff that we've already done. So because of that, like that was the hard part. We're going to go and do this. I just want to talk one more concept because this is the last question, and then we're going to be done. And we'll see this again. What we're actually doing here is a triple integral right now. We're doing a triple integral right now of 1 dv. This is a very important thing because I'm trying to find the volume, and this is the formula for volume essentially. Sorry. But then this dv, just like my dy dx, this is in terms of dz, dy, dx. Okay? Now watch this funny little thing here. I want to integrate 1 in terms of z. What do I get? I get a z. Oh my. See how a z equals? And that's why I'm popping that thing in here without thinking about it. Because why? Because this is z. Cool. So it is a triple integral. We are doing that every time, but we just don't have to go that far. Okay, that was all just concept. We'll see it all again later, but it's just fun little things like that. Okay, in terms of y, I'd almost want to just ask you, but it's way faster if I do it. No. But it's also more error prone. So, yeah, 5/3 y cubed, and I'm gonna go 0 to 1 dx. I'm not like trying to speed us through. I'm sure that you can integrate some polynomials, right? Right? Good. 0 cancels everything, so that's kind of nice. Integrate again. Actually, that would just end up a plain x cubed. Calculator, and we're done. Let me just jump. I mean, are y'all okay with like, just integrating like the polynomial stuff? We've been doing it a lot already. Cool. Oh, I need to flash the answers once in a while, don't I? Yeah, I haven't even been looking. Well, we don't need them. Yep. Okay, good. Good. Hey, look at that. We got it. Okay. So, whatever. Yeah, these are easy things. So we're done for the day. If y'all have questions, though, I am here for you, of course, as you know. I like anything more than that last section. I think the whole chapter was fine. It was that section was so brutal.
Yeah, that's why I meant last section, that chapter.
Thank you. Yes, I know. Oh, yes, that is so true. It was bad. I'm gonna turn off the recording. Are y'all good with that? All right, cool.